Alrighty, so that last video got cut off a little bit. Sorry about that. But we are on slide 11 now, and we're going to do the same thing, but find that average rate of change between 2 points. So again, the first thing I like to do is label those 2 points. Our first point is x1, y1. Right? We always label our points as x comma y. So x1, y1 is just our first point. And the second point we're looking at is going to be our x2, y2. Now when we plug them in the numerator for y2, which is -7, minus y1, which is 12. So we have -7 minus 12 divided by x2 minus x1. So our x2 is 14 minus 3. And this is finding the rise and the run between those 2 points. -7 minus 12, if you're not sure about that, you can always take it to the calculator. And we're doing -7 minus 12. Oops, be careful of your signs when you're typing this in. And we get -19. (14 minus 3) is 11. We can't simplify that. That's kind of as simplified as it can be. So our general average rate of change between those 2 points is down 19 and over 11. Okay. Slide 12, when you're ready. Same thing here. Label those 2 points. So here's our x1, y1. And then our second point is x2, y2. So in the numerator, we're doing y2 minus y1. So we have -1 minus 6 divided by x2 minus x1, right? Which is -2 minus -8. Notice there's a subtraction sign in there, so make sure that you don't lose it when you're plugging those values in. -1 minus 6 is -7. And -2 plus 8, which is what we get when we have minus a negative, is going to get us 6. So our average rate of change is down 7 and over 6. Beautiful. Push ahead to slide 13. Finding the slope from a table. So we were using a graph to find slope. We can find it when we're given 2 points, and we can also do it in a table. So the slope of a table is still, we're thinking rise over run, right? And this, remember, the rise is your change in y, and you're dividing it by your change in x, okay? So in this example, our change in y in the first one is going from 5 to 10. So thinking of those like sequences that we were looking at in the prior weeks. We're going up 5, and our x's from 0 to 1 are going up 1. So change in y goes first. So our slope is 5 over 1, right? Which we could just write as 5. We're going up 5 over 1, up 5 over 1. And we're following that pattern. These are linear functions in the table. For the next one, we're going from 6 to 12, and then 12 to 18, and then 18 to 24. Each time we're going up 6. That's our change in y. Our change in x is going from -4 to -2, -2 to 0, 0 to 2. Each time we are increasing by 2. So our slope that we see here is 6, that's our change in y, divided by 2. And again, we could reduce that 6 over 2 can be simplified to just 3. So our slope for that second table is 3. For the next one, our y is going up by 5, 5, 10, 15, 20 each time. And our x from 5 to 8 is going up by 3. 5 plus 3 is 8. 8 plus 3 is 11. So our change in y is 5 divided by 3 is our change in x. And then finally, for our last one, we have our y, which is going up from 0 to 40. So we're going up 40. And our x from negative 10 to negative 20, it's getting smaller, further away from 0. We're subtracting 10 each time. So our change in y is 40 divided by a negative 10, which can simplify to just negative 4. Beautiful. When you're all set here, push ahead to slide 14. Find the slope from a set of ordered pairs. So when we're looking at these ordered pairs, we can see that it's just very similar to doing it in a table, only now we don't have it in table form, we have them as pairs. So we're going from 0 to 5 to 10 to 15, right? We always write our coordinates as x, comma, y. So our y coordinates our y coordinates are going up by 5 each time. Our x coordinates are going from 0 to negative 4 to negative 8 to negative 12. They're going down by 4 each time. So we have 5 over negative 4. It's a negative slope, down 5 over 4. For the next one, our y values are going from negative 4, negative 7, negative 10, negative 13. So we're subtracting 3 each time. And our x values are going from 3 to 5, and then to 7, and then to 9. Each time we're adding 2. So we have negative 3 over 2. When you're all set, you can push ahead to slide 15. We can also find our slope or our rate of change from a contextual situation. We just need to write points, and then we can figure out how to find the slope. So it says a gym membership costs $40 to join and then charges a fixed amount per month. Jamie joined the gym. After 10 months, she paid $280. Including the cost to join with monthly fees. What is the monthly rate? So we have here our total amount. We know that they did it for 10 months and they paid some amount each month, and that amount is the same, right? It also costs $40 to just join the gym. And with all that information, we get a total of $280. So we're trying to figure out what that monthly rate is. So we can set ourselves up here and make an equation. When we subtract 40 from both sides, doing that opposite operation, we get 10 times the monthly rate is $240. So then we can divide both sides, by 10, 240 divided by 10 gets us that monthly rate to be $24. So our slope was $24 each month. So the price goes up 24 for each month, up another 24 for the next month, and so forth. Push ahead to slide 16 when we're ready. We have 3 more slides here, y'all. We're almost there. A climber is on a hike. After 2 hours, they're at an altitude of 400 feet. So that's kind of our first point, right? 2 hours, 400 feet. That's a data point. We have another data point that after 6 hours, they're at 700 feet. What is the average rate of change? So we can label these 2 points as x1, y1 for the first point, and x2, y2 for our second point. Now our slope formula, if you remember, we subtract the y's on top, and then we subtract the x's on the bottom. So for this case, we have 700 minus 400 divided by 6 minus 2. 700 minus 400 is 300. 6 minus 2 is 4. And again, we could simplify this further and say, well, what's 300 divided by 4? That's 75. So for each 1 hour, this climber went up 75 feet. Or over the whole 4 hours, the climber went up 300 feet. That's telling us that average rate of change. Okay. I want you to try 17 on your own. It gives you a table. I will say that hours, this is our x, and cost is our y. So I want you to find and pick 2 points, and then try and do your y2 minus y1, subtract those y's, divided by x2 minus x1 to find the rate of change for the rental fee. So pick 2 points, label them, and plug them in. Try that one on your own, okay? And then I'm going to do slide 18 as our final slide together. It says a salsa recipe calls for black beans. 10 ounces of black beans make 4 servings. So we have 10 ounces make 4 servings. We also see that 15 ounces makes 6 servings. Okay. And it wants us, it also gives us more. We don't need this many. We only need 2 points to find the average rate of change, but we also see another point is 25 ounces makes 10 servings. 45 ounces makes 18 servings. And we want to find the rate of change using units. So let's look at our original first 2 points. Here's my x1. Here's my y1, here's my x2, and my y2. Now again, our formula, subtract the y's, divided by, subtract the x's. So we have 6 minus 4, those are the y's, divided by 15 minus 10. 6 minus 4 is 2, and 15 minus 10 is 5. So this means there are 2 ounces per 5 servings as our final rate of change. So that's a big intro to slope and rate of change. Take those notes, get what you need down, and if there's anything I can do to support you, please send me a message. We can find a time to meet. Otherwise, I will see you all in the next video. So take care of yourselves. Until then, bye friends.